Hello, so this is going to take us through the 6.1 through 6.3 review. We're going to look at most of the problems here. The answer key is also posted in Plus Portals. So, first section, solve the following systems by graphing. This is implying that they will have a whole number coordinate crossover point. So here's what I'm going to do. I'm going to do them in different colors. This first equation, y is equal to negative x plus 3. I'm going to start at 3 on the y-axis. The negative x tells me I need to go down 1 to the right 1. So each of these down 1 to the right 1 spots could be a potential answer. All right, and in the other direction too, if I want to go up and to the left. Okay, our second equation tells me to start at negative 2. Its slope tells me to go up 4 to the right 1. So we go 1, 2, 3, 4 to the right 1. You may see right there, this red spot is where our two lines cross over. Right, so my lines don't encompass that accurately, but that red spot is where our slope dots crossed. If I had a straight edge on this, the lines would have also crossed exactly right there. And this coordinate point is 1, 2. If you plug that into both equations at the same time, it works for both equations. Alright, let's clear this out of the way. That was a negative x there. Alright, now the only thing that makes some of these a little bit more tricky is that the equations might not both be in y equals mx plus b. If they're not, just give that a fix before you start to graph it. So like on this one here, I could fix this by subtracting an x from both sides, really making it y is equal to a negative x plus 1. So I'll go ahead and graph this second equation first. I start at positive 1. And once again, I have that negative x slope, so down 1 to the right 1. All of these points. We'll see if that's enough. This second equation here starts at positive 6. And it goes up 3 to the right 2. Or down 3 to the left 2. And then there's its crossover point with my blue equation. And this coordinate point is a negative 2, 3. Alright, so that's the gist of this graph and the different lines with the different slope. One that could be tricky could be number 6. That's because you need to solve this second equation for y. So that involves us getting the x to the other side. And then we need to divide everybody by negative 4, leaving us with y is equal to positive 3/4 x minus 5. So this equation is this equation now in y equals mx plus b. Alright, what you might recognize is these equations are the exact same. So if I graph them starting at negative 5 on the y-axis and go up 3 over 4, both equations are the exact same, so this is an example of infinite solutions. Oh. All right. Okay, so there is that section there, graphing and finding that crossover coordinate point. This section here, tell whether the system has one solution, infinitely many solutions, or no solutions without graphing, and explain how you know. Alright, no solutions is going to be parallel lines, which means same slope. If our slope from one equation equals to the slope of another, that's parallel. Infinite is going to be the same equations. They are the exact same. And one solution is going to be different slopes. Alright, so working with this here, if I subtract this x over, makes this equation y is equal to a negative x minus 3. These equations have different slopes. They are guaranteed to cross over one time. All right, so this is one solution because they have different slopes. All right, this equation here. I could add the 2 to the other side, but that's not going to help the fact that they have the same slopes. So these are parallel. So that makes them no solution. All right, this one here, if we solve this top equation by subtracting 18x to the other side, and then divide everybody by a -3, you will see that this top equation here is really this. This second equation isn't quite solved for y yet. It has a negative with it. You divide everybody by that negative to get this. And then you might realize here, oh, and I made a mistake over here on this side. Forgot to divide everybody by the -3. Let's go back here. So this was initially a positive 21, but when I divided it by the -3, it should turn into a -7. Now, these two equations are the exact same, so this is infinite solutions, because both equations are the exact same. All right. Here on this page, it's asking us to solve with substitution. So there's a variety of different levels of difficulties on these. You know what's interesting about this first one? This first one trips people up, even though it's actually the easiest type of substitution you could have. It's saying x is equal to y. So if that's the case, if x is equal to y, I can substitute y in for x to get a y plus 2y is equal to 3. So 3y is equal to 3. Y is equal to 1. All right, and then if I plug that back into the first equation, x is equal to y, that means x is also equal to 1, making my coordinate point 1, 1. All right, but that problem tricks people sometimes because they're so used to seeing other numbers. When they see x is equal to y, they get stumped. Okay, substitution in this case, if y is equal to -x plus 4, I can substitute it in for that y right there. We're essentially setting these two equations equal to each other. Add the x to both sides, and you will get that 4 is equal to 4x, giving us x is equal to 1. Pick either one of those equations. I'm going to pick the y is equal to 3x, plug in the 1, y is equal to 3. So our coordinate point answer, point of intersection, is 1, 3. All right. This one here, couple options, but what you'd probably want to do, or what I would do, is recognize, hey, this is equal to y, substitute it in for that y. So now I've got 2 times 2x minus 10 is equal to x minus 8. We've got some distributive work here, so we have 4x minus 20 is equal to x minus 8. So I want to gather my variables on this side. So we got 3x. So I'm going to go ahead and gather my constants on the other side. So 3x is equal to a 12. X is equal to 4. All right, pick either equation to plug that back into. I'm going to pick the top equation. So I've got y is equal to 2 times x minus 10. My x is a 4. So we will get the 8 minus 10 to get that y is equal to a -2, making our coordinate point 4, -2. All right. Now, when it says up here to be checking our solutions, remember that means if you plug your coordinate point into both equations for x and y, it should work for both. Let me showcase that here on number 10. If I go up here, and I'm going to rewrite both equations. but I'm going to leave space to plug in my y and my x. And we should get a true statement. So there's the first equation. Here's the second equation. So I'm going to check this coordinate point. If I plug in 4 for my x's and a -2 for my y, we should get true statements here. All right, so this would be 8 minus 10 is a -2. So -2 is equal to -2. This one checks out. This one, I'd get a -4 is equal to 4 minus 8 is a -4. This one checks out. That's what it means to check your answer. All right. Okay. So let's start to skip around some here for us. Now for 12 and 13, it says up at the top to solve each system with substitution. And I've kind of changed my mind on these because you might notice these are begging for us to use elimination. Could we use substitution on these, like the instructions said? Sure, but I want us to be critical thinkers on these, and if you're ever given a scenario like this, and you got to choose, which I'm going to let us do on this, you should for sure use elimination. And then 13 is the exact same problem over again. So although we're on the substitution page, do feel free. Go ahead and solve this one here with elimination. Right, because it's so much easier. Right, I don't have a variable solved for, but when I add these up, the y's will cancel, giving me an x is equal to a -2. Plug that back into either one of the original equations. I'm going to pick the top equation. So get that -8 plus y is equal to a -2. Add 8 to both sides to get the y is equal to a 6. And we get our coordinate point of -2, 6. Could we have gotten that same answer by using substitution method by perhaps making this first equation y is equal to a -4x minus 2 by moving that 4x to the other side and then plugging this in for that y? Absolutely, you get the same answer. But this problem was just begging us for you to use elimination. So we did. Okay, so hopefully kind of see the gist of that. And there's a couple of repeats on here. 16 is also a repeat. All right, so there we go. So there is our concept of substitution.